The video that you just watched on the previous Nearpod slide hasn't been made yet. In other words, I'm making this video before that video, which is a little weird, but I think I know what you just saw. And if you're wondering, well, why'd you get all dressed up for that last video, the answer to that is for the comedy. I thought it'd be funnier if I had on a shirt and tie and I was getting egg all over my shirt and tie. But anyway, back to the more casual look, and I have a way for you to do a little experiment of your own. I wouldn't suggest the egg experiment at home. That might not go over too well. But you can do this. Most people have a cup like this. I get my face on the screen so I can see what you're seeing. These are pretty standard cups. If you have one of these, plastic, of course, I mean, you know, plastic or paper cup, don't use anything that could break. And you can flip it, you can use that cup. If you don't have one, don't have your parents make a special trip to the store or anything to get one. You can improvise, you can try some, you can look for some other object around the house that you can do this with and get the same idea. When a cup like this falls off a table, let's say it was empty and it fell off a table, there's three ways it can land. It can land on its side, shown here. It could land on the top of the cup, actually land like this. Or it could be sitting on the table like this, fall off and land on the floor just like this. It's possible. I don't believe you can calculate a theoretical probability for each of these possible ways that the cup can land. I just think there are too many variables. And this is a common situation where you can't calculate a theoretical probability. So if you'd like to know the probability that it will land this way, or this way, you have to do an experiment. But it's good before you do an experiment, before you collect your experimental data and make your observations to calculate experimental probability, it's good to make a prediction. So I'm going to make a prediction that I know is wrong so that I don't lead you, I don't want to lead your thinking. But let's say I believed these were all three equally likely. Well, there would have to be a 1/3 chance, a 1/3 probability of it landing each one of these three ways. Because if it's got to land one of these three ways, these three probabilities have to add up to one whole. That's that concept of complementary events that we talked about. It's certainly going to land on its side, on the top, or on the bottom. So those probabilities have to add up to one whole. With that in mind, I want you to fill in this part on your table with your predictions for the probability that the cup will land on its side, for the probability that it will land on top, like this, like on the floor like that. Actually, I've got a thing I can. The only thing is I'm not sure how well you can see it, so I've got to be. Let's pretend this is my floor. So landing like that on the floor. Side is like that. Doesn't matter how it's turned, just on its side. And bottom, we're going to say bottom is if it lands on the bottom of the cup. Like that. Okay. Once you make your three predictions, then do an experiment. If you imagine a cup getting knocked off a table, it wouldn't... Let me take a step back and think about the best way to say this. Whenever you conduct an experiment, you have to consider all the variables. Like, I had a student... This is one part of class that I'm missing a lot. The students have great questions. So one time a student said, well, how do we drop it? And I said, oh, that's a brilliant question, because if I conduct my experiment and I drop it like this, it's going to look like there's a 100% probability of it landing on top. But of course there's not. It's just the way that I conducted my experiment. I didn't conduct my experiment fairly. If I drop it like this, a couple inches above, it's always going to fall that way. So drop it from a good height. If you want to give it a little spin, whatever you think is fair. It's your experiment, so you decide what's fair. But in the same way that we refer to fair spinners, fair dice, You want a fair experiment. So that's not meant to be done in these on this table. It's just on on this not table, but on this table. I want your predictions here and your actual probabilities that you calculate from your experiment here. But on some other piece of paper or something, you can do like, I guess you can kind of do it here. You can just tally up how many times it lands on its side, how many times it lands on top, how many times it lands on bottom. And there are also other considerations like, well, how many trials are you going to do? You know what's best. I mean, we talked about this when we did the goldfish experiment. I probably talked about it in the last video you watched. So do a little experiment, collect some data, calculate probabilities from the data, and those are your experimental probabilities. And then it should be interesting to compare the probabilities calculated from your experiment to the probabilities that you predicted. And sometimes they'll be very close, sometimes they'll be way off. And then if they're way off, you want to ask yourself, I wonder why I thought that, and what might I not have been considering, or what have I learned when I watched them fall, things like that. So we'll do a bunch of simulations. Each one is a trial, and try that if you can. It's not like you're going to turn it in. Although I would be interested to hear on today's discussion board any thoughts you have or any predictions you made or things you learned from doing this. And again, if you don't have one of those cups and you can't think of a way to do it, you can be creative. Just make sure it's okay with your parents, whatever you decide to do.